Hey, what's up, everyone? This is your boy James. Welcome back to the How to Learn Data Science in Python on the DataCamp. I think it's episode number 15 or 16. I will correct it anyway. So today we're gonna talking about the clean data in the Python, and this is a short series. I think it's total hours like 4 hours. But yeah, long story short, let's just jump into it.
Welcome to the Data Cleaning in Python course. Python is growing as the language of choice for data analysis. Users can do full-stack analysis in Python by creating systems to collect data and pipelines to clean and analyze data. Data analysis is more than just fitting models, getting a number for effect size, and significance values. Most of analysis actually requires understanding, tidying and reshaping, cleaning, and combining data. If you know the basics of Python for data science, or know a bit of pandas or NumPy, then this course will expand your skills as a data scientist. We will focus on the steps of data cleaning. Look at your data, tidy and reshape your data, and clean and prepare your data for model fitting. This course is focused on cleaning data, with the end goal of producing a dataset that can be used to fit a model. However, the process of data analysis is an assortment of steps and tasks. During the data cleaning process, you'll discover aspects of your data that will inform other aspects of analysis. For example, feature engineering and model fitting, which is not necessarily data cleaning. By getting our data into pandas and out of spreadsheet programs, we begin the process of automating our analysis pipelines. It gives us confidence that our analysis can be replicated even when the underlying dataset changes. This sets the foundations for automated reports or reproducible scientific research. These are the steps and tools we as data scientists spend the vast majority of our time on.
All right, so see you guys in the course, right? Um, Start. So, okay, diagnose data for cleaning. Let's go.
Cleaning data is a process of preparing your data set for analysis. It's important because data almost never comes in a way that does not need to be cleaned. This chapter is going to cover how to diagnose your data for problems that require cleaning. Here are some common data problems that you will learn how to clean. Column names can have inconsistent capitalizations and or bad characters. Missing data needs to be identified and addressed. Outliers can pose a potential problem and need to be investigated. Duplicate rows can bias analysis and need to be found and dropped. Untidy datasets can contain multiple problems and prevent us from quickly transforming our dataset from one suitable for reporting to a dataset that is suitable for analysis. Other common data problems are processing columns before a column can be used for data analysis, and column types can signal the presence of unexpected data values. We'll go into more detail on what these mean throughout the course. This is a dataset that we've adapted from the European Environment Agency. It gives the percent of females aged 15 or over who can read and write, the average number of children that a woman will give birth to, and population for a given country in a continent. We have row indexes and column names. An index in pandas is the basic object storing the row labels. You can reference indexes for rows and columns by their labels or by integer. Looking at the first few rows can identify some of the common data problems already. We have some column name inconsistencies. Country and continent are capitalized. Female literacy has a space in it. Missing data, which is data not present for whatever reason, these are represented as the NaN values. And the country names are in French. To load the data, we begin by importing pandas library with the standard alias PD. The readCSV function takes a file name and loads it into a data frame called df. We can visually inspect the first and last 5 rows of our data frame using head and tail methods, respectively. Here, we see the column name inconsistencies, missing data, and columns that need to be further processed. If you have a lot of columns, calling the columns attribute of our data frame will return an index of column names. You see that the country column actually has a space at the end of it. This was practically invisible when we look at the head and tail of our data. We can call the shape attribute to look at the number of rows and columns of our data. This is useful if you cannot visually see all your data with head and tail. Our data has 164 rows. A quick Google search shows that there are 196 countries in the world, so not every country in the world is listed in this data set. We can use the info method to get additional information about our data frame. This is a pandas data frame object with 164 rows and 5 columns. The population column only has 122 non-missing values, so we can subtract 122 from 164 and know there are 42 missing data points. The fertility column should also contain numeric values, but it's stored as an object instead. An object type is a generic type in pandas that is stored as a string. Numeric data types will be represented as an int if there are no decimals, and a float if there are decimals. We will want a closer look at these missing data points and wrong data types, but for now, it's your turn to load a data set and visually inspect it.
Okay, let's just do it, right? So load and view the data, right? So NYC open data, what is that? Let's see. It is open data for all New Yorkers. Republic. Okay, open data for New Yorker. So your first task is to load the data set into data frame, then inspect the read, head, tail, shape, column, subset, blah blah blah, right? If you guys just look at the keywords, you probably know what he asked us to do. So get the head, get the tail, look at the shape of the data frame, look at the column, look at the subset. Okay, so first, let's just do that in the fly. Import pandas as PD. And the PD.read CSV, and give the name. This is the name, right? Paste here. See if we can run that. Control plus enter, right? Plus print PD and its column name. Head of the PD, head. So, okay, so this is a job, doctor, what is this, horse, street name, state, zip code, owner's phone. It's kind of messy. So did he have some like a tidy print? We probably will learn that later, but probably not now. They didn't tell us how to do that. Or maybe, like, let's see, Python tidy print. Tidy print, p print, okay, plus a p, is that the way? Has been turned off. Okay, so obviously we cannot do that here, but okay, probably the same. I cannot see much. Shape, df shape, right? Run. Print name is not defined. Oh, we just run this line. What? Turbo object is not quotable. Okay, let's say shape. So shape, print the shape of data frame dot shape and the column. Oh, attribute is not matter. So you don't need to follow with parentheses. 12,846 row, 82 columns. That's a big one, to my opinion. You may differ. And pd.columns. Oh, that's a lot of columns here. Like, let's just ignore. Let's just keep going because this is hard to identify what they are. Okay, maybe just look at. So your job, doctor, what's this, horse, street name, block. This is kind of like street, right? Cluster, then a PC field, sprinkler, other, last name, people's name, application, profession chart, and what they are, and then hit the submit answer. Subset. Just one. Print. Oh, okay. Print tell. Get rid of that. In addition to suspected number of zero value, which may represent missing value, notice that the column that contain initial cost and total have a dollar sign beginning. Those columns have been coded as strings instead of numeric. Okay, so those are string, right? Man, like this is the hard part because I mean, to me, I don't know for you guys if it didn't print out as a R, like the data frame column value, and but it's just in a string like this, it's really hard to read. So I don't know, like he said, like here's a suspicious number of zero value. I think he's mentioned here, but you don't know the column name, so it's really hard to tell like what this value is until you count the position. And I'm probably not gonna do it over here, but you get the idea. So next, further diagnosis. So info, right? So with pd.info. Say, okay, let's see what we have here. Let's shut it down up a little bit. So before we go too much deeper, okay, he said the initial cost and the total as the fee. Let's look at those two columns over here. Where is initial cost? It's really hard. I mean, like to my opinion, it's really hard to just look at the column name and look at the attribute and here to see if it makes sense or not. I mean, if you have 10 column, you can look at one by one. Probably it's like easy to tell. I mean, number is the int, okay, but house number is the object. Oh, okay, so this one probably not right. It should be a number or something. Or maybe it's just different house have different style. But I think like 80 some is really hard to tell one by one application license number, why it's the object, right? So initial cost, if you can find it, or this total estimated fee are numerical string to whether or not those columns have data in them. Some that have been preloaded, you test it to method to see analyze them. It's really hard to see. Maybe let's just find one, like see if it didn't make sense. Okay, city, I think it should be a string rather than an object. And then let's look at the subset, right? Print df df what? Df subset, right? Df subset and dot info. Okay, so this is much easier. Job in docking, this words I don't know. Initial cost is object. He said like it should be a string or something. Fee should be a string, right? It shouldn't be an object. And those are all in the int. Maybe it should be a double, right? Like those are decimal should be like square feet or something. But anyway, submit. Why it's don't like it? It's not defined. What is not defined? There's third thing. Oh, here. Let's get rid of this and the submit. Bang, right? Excellent. Notice that column initial cost of fees or type of object, the currency sign in the beginning of each value of this column needs to be removed. Okay, that's what they're talking about. So let's see. Right hand. So those dollars that he said should be removed. And the column needs to be converted to numeric, right? Understand. And the full data frame notes that there's a lot of missing value. You saw in the previous exercise, there's a lot of zero value, give the amount of data is missing. The full data sets are highly recommended. There are likely that zero value represents the missing missing value. I mean, depends what it is, right? Okay, let's keep going.
In this video, I will show you how we can use exploratory data analysis to help identify data that need further investigation. The most basic analysis we can do is count the unique values in our data. We can use the info method to get the data type of each column. Here, I will show you the frequency counts for the non-numeric continent, country, and fertility columns, and the numeric population column. To perform a frequency count, we first select the column we want to perform a frequency count on. If the column name does not contain any special characters, spaces, and is not a name of a Python function, we can select the column directly by its name using dot notation.
Okay.
It works the same way as subsetting using bracket notation. Once we have the column selected, we can use the value counts method on the selected column. I like to use the drop NA equals false parameter since it will also count the number of missing values if there are any. The continent column does not have a missing value, so none will be reported. Value counts will print out the counts for each unique value of a column in descending order. Note that even though we counted a column of the object dtype, the results of value counts will be of dtype int. Another way we can select columns is using the bracket notation. Here's the same code and output as before, this time using bracket notation to select a column. Now we will count the number of observations for each country in our data. Since there are too many countries to show at once, I'm using the head method to only return the top 5 counts. In this example, I'm chaining together methods. I'm slicing and getting the value counts just like before. We expect each country to have only 1 observation, but Sweden has 2. This will require us to investigate this data point further. The fertility column is the column we expected to be numeric, but stored as a string. This is because we have a string named missing in the column. This is why the fertility column has the wrong dtype. It also alerts us that we need to recode the missing string. If your column has missing values, they will also be counted, provided you pass the drop NA equals false parameter. Here you see we have 42 missing values in the column. Another type of EDA we can do is calculate summary statistics on numeric columns. This can help spot outliers in our data. There are many working definitions for outliers. One definition is a value that is considerably higher or lower than the rest of the data. You can consult the DataCamp statistics course for more detailed definitions of outliers. Outliers are observations of interest we want to investigate further for data cleaning. We can quickly calculate summary statistics on our data by using the describe method. Only the columns that have a numerical type will be returned. Describe returns a number of non-missing values, the mean, standard deviation, minimum, 25th, 50th, and 75th percentiles of our data, where the 50th percentile is the median, and finally, the maximum value of our data. A quick scan down the population results show that the maximum population value is 2.3 billion people. Our data comes from 2012. No country had this population then. Now it's your turn to calculate descriptive statistics for exploratory data analysis to see what needs cleaning in your data.
Okay, let's do it. So describe, right? Okay. In this exercise, column initial cost and the total initial fare has been cleaned up for you. So those has been removed and have been converted to numerical values, right? And you know how to do stuff. The job, blah blah blah. Go dev, the receiver free. This clean data frame has been preloaded at dvf, and job is like this. This is hard to read. So This is really hard to. Wait a second. This is one. Let's see his video over here. Like so I want to.
Where the fifth
Okay. But why there's so many like unwanted information over there? I use describe, right? df.describe. Are we supposed to only look at here? Hmm. I think it's all thing. This is the whole thing. Man, I cannot get it right. And since it's really hard to read in this such way. Oh man, I can't. Okay, I give up this one because it's hard to read. Not correct. Okay, I know. Man, how do you read this one? This is one part in Python. It's not friendly. Propose of star means 8.44. I don't know which column it is. Let's not complain. Let's try. Right, like this is this guy. Is this the height? Standard deviation. Da da da. Okay. Maybe this guy? This is interesting. On to some. Okay, this is a true street fortune. 1, 2, 3, 4, 5, 6. Oh, how about this one? I don't know. Oh, okay. Please print it out. Can only use for numerical columns. Okay, so you can diagnose the data is when you have a category dot value content method. Bar roach dot value content value counts. Drop false, which is true default, so you will keep the null value here. So there's no null. Print out the count value state. df state show up. Okay, state not value counts drop not false. Okay, interesting. There's no null. State have quite some values over here. Let's actually go to look at the project state and the still fail column. Pandas. How to save column names. List data for column value. Let's see how is that the underscore. I think if you don't use bracket and the code for this column, let's say how to form df content. Stay here. I think it's a space. State field. Okay, so it's a space. So we have to code, I think, here. Side fell. Don't like it. Oh, there's no block. Okay, not applicable. No, 4,205. So what do I ask the point value of those? I really did. Fantastic work. Notice how not all the values stayed. What? Notice that not all the values in the state column are why? Of course. This is interesting find as the data. Oh, I see. Man, this is the key. This is when you do the data cleaning. You gotta think about those questions because previously he threw hints that okay, this is the NYC's data, but turns out it's have Jersey, Pennsylvania, California, Ohio, right? Illinois, Florida, Connecticut, Texas, New Tennessee, Maryland, DC, Georgia, Maryland, Massachusetts, Kansas, Virginia, Colorado, Minnesota, Arizona, Wisconsin, Utah, I don't know, RA, North Carolina, blah blah blah, Wyoming, Miami, Indiana, blah, right? What is this word? You guys know this word. Translate. Change to Chinese. Oh, okay. Ball.
Borough.
Borough. It's town. Why do we just say town? A good start as why this time calls may be found in look at the code book in the database. Also, for the state field column, you may or may not need to record an acceptable application to null, and you'll find it analyze. Not need to record this value to null. So those are the good questions. Okay, keep going.
Visualizing our data is a great way to spot outliers and obvious errors in our data. Data visualization is more than just looking at patterns and reporting data. They can also be an effective way to spot outliers and plan your data cleaning pipeline. Here's the tabular form of summary statistics for a clean European Environment Agency dataset. You can imagine how overwhelming the results can be on a dataset with many more columns. This is why it's important to visualize our data, because abnormal data points, such as the max population, would immediately stand out. We use bar plots to count discrete data and histograms to count continuous data. These plots will give us the ability to look at frequencies of our data, which can be used to look for potential errors. Here's an example of a histogram. We take the data frame and column of interest and call the plot method. We pass hist into the method to have pandas create a histogram. We have to make sure matplotlib is loaded before we can show the plot. Here is our histogram. The x-axis shows the range of values that are counted, and the y-axis is how many observations in our data are in a particular range of values. Our histogram shows two observations between 1 and 1.5 billion, and one observation above 2 billion. This dataset comes from 2012. At the time, it was impossible for a country to have over 2 billion people. We can slice our data to look for all data points where the population is greater than 1 billion people. We use bracket notation to slice our data, and inside, we specify the condition we are interested in. Countries with populations greater than 1 billion people. Our dataset reports Australia having 2.3 billion people. This is a data error. China and India are also outliers in our data, but those values are correct. These countries are actual outliers.
Okay.
Not all outliers are bad data points. Some can be in error, but others are valid values. Let's see what this data set looks like in other visualizations. Box plots are a good way to visualize all the basic summary statistics into a single figure that we can use to quickly compare across multiple categories. You can see the DataCamp statistics courses for more information. We can spot outliers, the min-max of our data, the 25th, 50th, and 75th percentiles of our data. We create box plots by calling the box plot method on the data frame. To plot just the population column, we pass it into the column parameter. We pass the by parameter the column name we want to compare box plots across. Here, I want a separate box plot for each continent in our data. Remember to show the plot. Here's the box plot of our population column. Most of our data is represented by the box. The lines that extend from the box are called whiskers. The ends of the whiskers show the maximum and minimum of our data, excluding outliers. Any outliers are values shown beyond the whiskers. You can see the three massive outliers of our data, one of which we know is bad data. The other two are actual outliers. Scatter plots are used to look at relationships between two numeric columns. In the exercises, you will use such methods to flag potentially bad data. You will also use scatter plots to identify candidates for bad data, which you will normally not see when plotting histograms or box plots, such as countries with low literacy and low fertility.
Okay, let's go, right? Visualize single value variable with historical data existing zone square plot. Import matplot lib.py plot as pyl. Do you guys remember as what? Well, let's just put it this way. Plot method always allow you to create a plot for each column, right? Okay, so what are we gonna plot here? Right? So you have all the stats over here. Max is 2.3. That's big. But those are all zero. What happened? Like something's pretty skewed the data. Plot method allows you to create a plot each column, the data frame, the kind, the parameter allows you to specify type of plots, kind is the hist. So it's hist, right? Plot the hist. Exists zone square. Go here. Value counts, right? Wait, what do we plot here? Not quite sure. Notice there's extremely large. Okay, yes, min max. I already know. Log x equals true. TRUE. Log y equals to true. PLT. Sure, I think it's something you should probably notice. You get the hint. What do we plot over here? Describe? Show the answer. I'm confused. Oh, plot. That's the plot. Oh, okay. There's a frequency and this is x-axis. What is this? Existing zone square. This is the biggest one. This is the count. Okay. Interesting. So while the visualized data is a good way to understand, keep in mind that no one technique is better than other. As you said, you still need to look at the summary study to help you understand your data better. So max and min, like min means like this guy means 0. Max is 2.8 multiplied by 10, like square 6. You expect a larger amount of the count on the left side on the log because 25, 50, and 75% have value of 0. This slide shows that there is a barely any counts near max value, significant an outlier. Rich people living to those max, maybe you're gonna move to that one day. Visual, at least I'm gonna do visualization, multiple variable with box plot, right? Okay, Panda already did. Let's see, like what we got. Initial cost column equals to here plot column initial cost. Okay, coded for oops. Oh, df dot box plot. Box. I think we need to code it. Okay, code. Bonjour is not defined. Let's spell it wrong. No proper column name. Quick box value across. Okay, let's see here. Go to visualize for different variable refers to when you want to visualize by how information that others box. Yeah, box bar. Oh, box box bar plot, and then like PFP, and this is not the app. Not sure. Here we go. Different towns and the counts of initial cost. Two outliers. Okay, here Manhattan. Another issue gets represent so that Manhattan extremely expensive. The outlier may be valid data point again. Future escalation is needed to determine whether or not you drop or keep this point. Okay. Visualization multiple variables and scatter plot. Okay. Plot kind is scatter with excesses. Initial cost and total estimation fee. Create the display second scatter plot. Okay, let's see. Let's first see this guy. Scatter. Let's spell that wrong. Oh, cost is quite big outliers, right? Now this guy's. If you saw my Manhattan again, what is rotate 72? Rotate axis level centers. You can see the rotation. Subsetting in the place of df. Let's type it. Df subset Better x equals to initial. Okay, that's interesting. 200,000. 200,000, 400,000. 1,000,000. 5,000, 10,000, 15,000. That's interesting. Okay, excellent. In general, if before I click, do you guys know what he can say? I think those codes are not mine. It's minor thing. Actually, the key is like what he observed over here, right? Excellent work. In general, from the second plot, it seems like there's a lot of strong correlation between initial cost and the initial fee. In addition, take note that large amount of points that have the initial cost of 0. Here, it is difficult to infer any trends of the first plot because this is dominated by an outliers. So what he says over here, like, oops. Go back here. Come on, okay. Outlier difficult first part because it's dominated by the outliers. So you guys show you guys outliers again. In here, this value is too big, and then it's like $100 million like over here. So you cannot see. Those are like very hard to see. That's what he's talking about. Tidy. Are we done this chapter?
Data comes in a wide variety of shapes and formats. Hadley Wickham wrote a paper about tidy data in 2014 that formalizes the way we can describe the shape of our data and gives us a goal when formatting our data. He states in his paper that tidy data provide a standard way to organize data values within a data set. There are many reasons why a standard approach to data cleaning is good, and a tidy data paper is worth the read to better understand how the shape of data fits into the various components of data analysis. Here's an imaginary experiment adapted from the tidy data paper. Each individual has a treatment value for each of the 2 possible treatments. Here's another representation of the same data. The information conveyed in the tables are exactly the same. This is why we need a more formal and standard way of describing the shape of our data. There are 3 principles of tidy data. The first is that columns represent separate variables. The second is that rows represent individual observations. And the last is that each type of observational unit forms a table. We won't cover the last point in this chapter. In our treatment data, the columns do not represent separate variables. They represent different values, A and B, for the variable treatment. We can reorganize the table of values into this new tidy format. Each observation will contain the name, the type of treatment, and its result. At first, the format of our data may be strange, and some may argue that the information is harder to ingest because it's not as easy to compare treatment differences for a particular person. But that's partially the point. There are data formats that are better for reporting and data formats that are better for analysis. If we aim to make our data tidy during the data cleaning process, we can fix common data problems along the way and be able to quickly transform data into different shapes as needed. Wiggum defines the data problem we are trying to fix as columns containing values instead of variables. We fix this data problem by using the pandas function melt.
Melt.
Here, I've saved the treatment data into a data frame named df. To melt our data, we first specify the data frame we want to use and which column or columns we want to hold constant. Here, we want the column that stores the names of people to be fixed, so we pass that into the id vars parameter. The result is a melted data frame where we have a column called variable that holds the treatments and a column called value that holds the treatment values for a given individual. Melt has a parameter called value vars for you to specify which columns you want to melt. If you don't specify this parameter like we just did, Melt will use all the columns not specified in the id vars parameter. The default variable column name is not always what we want. We can rename the new melted columns with the var name and value name parameters so we have more meaningful column names.
Okay, so it looks like this is another episode. So I will shoot that next time. So hope you guys enjoying this episode about clean the data, and see you next time. Peace.